Hey everyone, welcome to this explainer. Today, we're going to totally demystify this fascinating multi-step assembly line that basically takes raw, chaotic internet data and transforms it into the incredibly smart AI models you use every single day. If you've ever played around with an AI chatbot or an image generator, you're interacting with the final product of a massive, highly structured process. And today, we're going to walk through that exact process, step by step.
But hey, before we get to that polished, finished product sitting on your phone, we've got to ask a pretty fundamental question. Where do these AI models actually learn? I mean, an AI doesn't just wake up one morning knowing how to write a sonnet or debug Python code. It has to get that knowledge from somewhere, right? So to understand that, let's step right into the very beginning of the AI data pipeline. Section 1, the raw material, large public web datasets.
Okay, let's dive into this. Engineers use these automated systems to scrape just massive volumes of public data to build their datasets. We're talking websites and articles, capturing online forums and discussions, and grabbing public documents and reports. They even pull from open source code repositories, educational resources, and public images and videos. The entire goal here? Diversity. By pulling together all these different topics, writing styles, languages, and formats, engineers expose the model to this incredibly massive, broad view of how information actually appears out in the real world.
Section 2, the refinery, cleaning and structuring. So let's quickly walk through the first 3 steps of our factory floor. Step 1, like we just talked about, is collecting that diverse data. But step 2, that is where the heavy lifting happens, because raw data is incredibly disorganized and messy. Engineers have to vigorously clean it and filter out the noise to improve quality. This means stripping out duplicates, tossing away spam and low-quality content, getting rid of corrupted data, and absolutely filtering out harmful or unsafe material. Finally, in step 3, this newly cleaned data has to be formatted into machine-readable inputs. Now, what's really interesting here is how they actually format it. An AI doesn't read a sentence like you or I do. Instead, it relies on a process called tokenization. Basically, it breaks text down into smaller pieces, or tokens, so the model can actually process it efficiently. And it's not just text. Images are resized and normalized, while code and documents are given a rigid structure. We are literally translating human content into a language the machine can digest. Section 3, brain training, how the model learns. All right, welcome to the engine room, step 4. The model learns through a relentless cycle of trial and error. First, it makes a prediction, like guessing what the next word in a sentence should be or trying to identify a label for an image. Second, it compares its prediction to the actual real data. Did it get it right, or was it way off? Finally, it adjusts its internal parameters to reduce its errors for next time. And it repeats this cycle millions, actually billions of times, gradually building up a statistical understanding and getting smarter with every single batch of data. And as you can imagine, this massive learning cycle requires some pretty incredible computing power. If engineers relied on traditional hardware, this training process would literally take months to complete. But by using large graphics processing units, or GPUs, and tensor processing units, TPUs, the hardware can operate in parallel. This massive, coordinated crunching of numbers impressively shrinks the training time from months down to mere days. Section 4, quality control, evaluation, and testing. Before this thing leaves the factory in step 5, the model faces rigorous testing on entirely separate datasets, stuff it has never seen before. That proves it hasn't just memorized the training data. Engineers are checking for overall accuracy, making sure the model's predictions are actually correct. They run strict bias and fairness checks and perform intense stress testing for edge cases, basically throwing weird, unexpected prompts at the model to see if it breaks or behaves unpredictably. Section 5, deployment, fine-tuning, and APIs. Let's move to step 6. This is where the base model is fine-tuned using human feedback, so it's more aligned, helpful, and task-specific. Taking the model out of the factory and moving it to a live production environment means it can finally be made available to real users and systems, making predictions on fresh, live data. Engineers continuously monitor its performance and retrain it as necessary. But to actually connect it to an app or service on your device, it needs a bridge. And that bridge is an application programming interface, commonly known as an API. To put that into perspective, an API is exactly like a server at a restaurant. You, representing the app, are the customer. You don't walk back into the kitchen, which is the massive, complex machine learning model we just built. No way. Instead, you simply tell the server, the API, what you want. The server takes your order to the kitchen and brings the results right back to your table. You don't need to know how the kitchen cooked the meal, you just need to know how to place the order. So, the crucial point we are left with is this. While public internet data is the foundational raw material for these incredible tools, it leaves us with an ongoing heavy debate. The data is sourced publicly, sure, but is all public data ethically or legally suitable for training? As AI models grow more and more powerful, where exactly should the line be drawn on using the public internet as a classroom? It's a wonderfully complex question that will absolutely shape our future. Thanks so much for joining me for this explainer, and I'll see you next time.